In this video, you'll see why airports can and must use mobility simulations to properly plan for social distancing in confined spaces using Autodesk Infraworks and Autodesk 3ds Max. MicroSimulations are run using Autodesk Infraworks. As a basis for our project, we'll be using a Revit model, a wide variety of 3ds Max elements to provide realism, and assume a 20% reduction of original traveling demand. Simulation will be run from 6 to 10 a.m., where this airport holds the peak volume of arriving and departing passengers. As passengers arrive, they'll be checking in by either using kiosks or first and business class counters guided by line dividers, always spaced 6 feet apart as per new security guidelines. Proper layout by itself does not guarantee constant flow, nor complies with safety guidelines. The model behaves as an integral dynamic network. All moving parts in an airport must be simultaneously considered during microsimulation analysis. Mobility simulation must be performed to reproduce people's behavior throughout time to analyze and control crowds based on walking speeds, maximum queue capacity, time delays, and compute necessary number of agents to provide constant flow and an adequate level of service without collapsing the network. After check-in, passengers head to departure gates in a very limited amount of space and time. Departure areas also depend on queuing geometry, number of agents, and physical spacing on both security and passport areas. If security and passport sections overfill, departing queues become static and the complete network collapses. If departure lines are excessively long or incorrectly paused, check-in demands overflow capacity. Furthermore, passport queues won't only have to be designed to safely hold passengers, but also need to withstand the flow and velocity of people security constantly provides. A longitudinal wall also limits the space to place additional agents and the ability to increase queue lengths. The key to resolving the problem resides in running microsimulation balancing queue geometry, demands, waiting times, start-stop locations, physical restrictions, walking speeds, delays, and necessary number of agents to avoid collapse, providing distancing everywhere and simultaneously. Simulation also provides advanced tools to compute time, location, and duration to hold, release people to maintain proper balancing. As people deplane, spacing in corridors is verified to reach passport control areas. Doors must be relocated, a necessary number of additional security agents is computed without collapsing the network, finally reaching the baggage claim areas, maintaining distancing. At any point, reports can be created and visual feedback can be enhanced by visualizing a safety distance ring or a buffer safety circle around each passenger to constantly analyze proper distancing. Microsimulation is imperative for all airports to guarantee social distancing, avoid network collapse, optimize number of airline representatives, compute start-stop times and locations, design queue geometry, provide adequate levels of service, and even allows airlines to compute boarding schedules, maximizing the number of people without crowding the aisles. Thank you for watching.